Okay, welcome back. Today is September the 4th. Happy Friday. We're going to cover something called lesson number 2, which is using equations to solve problems. Said another way, today is our first day tackling word problems. First of many days talking about word problems. I know that there are going to be some growing pains with my math lab in the beginning of the semester as we get used to this new piece of software, and most folks who have tried have been able to get in successfully. There have been a couple of Mac users who have had some technical issues, and one other person using Windows 10 who's had some technical issues, but I expected that that would happen for a few people, which is why I gave a week for the first assignment. So the first assignment typically would be due today. Homework is always going to be due the very next class, but these first two assignments, I'm giving you some extra time here. So September the 9th, which is Wednesday coming up, that's when the first homework assignments are due in my math lab, okay? All right, so I think that's good there. Just a couple of other quick things in the beginning of the semester here. First of all, you'll notice I'm wearing a Bluetooth. Every class that we have together, I'm going to record everything that I say and everything that I write on the smartboard. And if you're able to find my videos, let me just show you what you can expect to see. So this is from last class. Something times x minus something times x. What is 7x minus 4x? 3x. How did we get 3? 7 minus 4, right? So apparently what we're supposed to do, so I'll write it out here, 7 minus 4. Okay, so you can relive the magic that was Wednesday if you go on YouTube and find this video. So there are a couple of ways to get here. First of all, my videos are all going to have a certain format, and that might be the quickest way to just search for the title of a video. It's the semester fall 2015 096. Class 1 is what we did on Wednesday. Today's video is going to be exactly the same, but class 2. And if you can't keep track of the numbers, that's no problem. It's these numbers right here, lesson number that you have on the syllabus calendar, right? Another way to find the playlist, I'm going to put all these videos this semester in a playlist, is to log into our Moodle site. And there's just a direct link to the playlist here, okay? These videos will be posted like right after class ends every day. So if you miss a class, this is the next best thing you can do. It's not the same because you're going to miss all the activities and working with each other. But anyway, it's here for you. And if you wanted to see something again and you're here, you can just check it out. Questions on that? All right. So one last piece of business, and then we'll jump in here on page 9. If you are taking this course again, if you took 096 before and you're taking it again here, you can reuse your My Math Lab login from last semester. You don't need to repurchase an access code for what it's worth. You would just sign into our course instead of going into the old course that you had, but it's the same access code, same username and password. All right. So we'll jump in here at the top of page 9. Malaya, could you read the daily summary for us? Okay, 0. Abby? Okay, so just a broad picture view. The demo is the part where I kind of lead the discussion up here at the board. I try to keep it short, 10 to 15 minutes maybe on average, and the bulk of the time will be you guys working with each other on something that I'll call the activities. You don't need to go here right now, but this is 2 pages away. This is how you will spend most of your time. As Abby just read, the expectation is that you will complete all of the activities. You'll know when you're done because you'll get to this thing that says answer key to the activities. And for some of you, that will happen during class. But if it doesn't happen during class, I'm expecting that you will spend the time outside of class to, at minimum, finish the activities. For those people who want more practice besides the activities, and for those people who finish the activities in class, there's even more practice. So again, as Abby read, the expectation, minimum, you'll finish the activities. But even if you're a speed demon and you finish them in class, that doesn't give a reason to just start chatting and texting and doing all these other things. In class, we're doing math, and there's always more problems that are available to you to do. So even more practice is there. As usual, there's going to be an answer key. Okay? All right, let's keep going. Taylor, you're going to read this next thing here. Oh, Taylor's not quite ready. Can we go to Kelsey? Can you read the if part? Okay, so my math lab is generally quite accurate in terms of reading answers, but if you type something in and you think it looks exactly like what they say the answer is, but they said you got it wrong, send me an email. I don't want people to spin their wheels and get really frustrated at the software. There's a link right there. It says, send your instructor an email or ask an instructor a question or something. Just, I'll take a look at it, and oftentimes it's something small and silly and it's easy to fix. In terms of, again, not getting frustrated with my math lab, there's this other handout on your tables, so go ahead and grab one if you haven't already. I got this from a website that's listed up at the top. This is a couple of techniques on the first page, and then starting on the next page is some basic advice for new folks using my math lab, new students using my math lab. It maybe will take you 10 minutes to read through this, but I encourage you to read through it at some point in the next few days. You might save yourself a lot of frustration and anxiety. The software is pretty straightforward once you get the swing of things, but right now many of you are using it for the first time, and if stuff isn't obvious to you, this might save you some time and energy, all right? Okay, so I think we are ready to jump in here with number 2. Can we go to Carmia for number 2? Okay, let's pause right there. So we got lots of numbers in this problem. Normally the cruise costs $2,752, but if we go with a group, the cruise director is willing to discount the ticket price for each of us by $1.75 for every person that's in our group. So the bigger the group, the cheaper it is for each of us to go individually, right? Not you? Okay, I'll take it back, thanks. And the goal is to figure out how many people we need to bring in to get 2,500. That wasn't yours? Oh. I already had one of those. No, well, wasn't your name on it? Hmm. Okay, so the goal is to figure out how many people we need in order to get the price down to $2,500 per person. Now, there are 3 numbers in this problem, and it is quite possible that some of you know exactly what to do with those 3 numbers to get to the answer to this problem. That's not going to describe any of you. It might not describe any of you. And even if it does describe you, I don't want you to do it that way anyway. This is an algebra class, and we're going to be doing algebra here. Oftentimes in a word problem, the first thing people do is try to write down some equation with a variable, x. At the moment, I don't want to do that because I don't even know what x might represent. I'm going to just pause a little bit. X is quite an abstract thing. It's a generic thing. I want to try to get my hands dirty and figure out what's going on with this problem by using some particular numbers. Instead of some generic x, let's say that we have 10 people traveling in the group. I just made up the number 10. If there are 10 people in the group, do you guys buy that we should be multiplying 10 times $1.75? Right, because that's how many discounts of 175 we get. So we multiply those 2 numbers. What does 1750 represent in this case? The total discount that we're each going to get, right? So how should we figure out how much we'll pay? Subtract 1750 from what? Give me a specific number from the 2752, right? If we do the original ticket price 2752 and we subtract off the $17.50 discount, that leaves us with what we'll actually end up paying individually, yeah? Okay, I want you to fill in the next row right now. I've made up another number, 50 people are traveling in the group. Feel free to use your calculator. And then we'll come back together momentarily. Check with your neighbors too. Okay, first thing we're doing is multiplying what by what? 50 by the 1.75. Somebody help me out here. What is that? 2750, thank you. And then that's the amount of the discount. So we're going to take that away from what number? From the 2752. What is that there? Thank you. Okay, so that's how much we pay. Makes sense that it's less than the 2734, right? Because if you have more people in your group, you'll each pay a little bit less. Super. Okay, let's come down here to number 3, where we'll take a slight detour. I think we're around here, Ryan.
The quantity is anything that can be counted or measured, like weight, area, number, volume, time. The unit is fundamental amount of some quantity, like inches, pounds, square meters, hours, cubic feet, hours. You have a quantity word and a unit word, and you don't know which sort of random word that makes sense.
Okay, let's pause there for a second. So we've got these two definitions, quantities and units. Quantities are things you can measure or count. For example, you can measure length, you can measure somebody's height, you can measure somebody's weight. We could find the area of the carpet in this room. Lots of things that we could measure. Those are all called quantities. The thing that we are using to count or measure all of these guys are called units. So for example, if I wanted to measure your height, your length, what unit might I use? Inches. What's another unit we could use? Feet with inches. Any other units we could use for height? We could do centimeters. We do miles. I could do miles, right? I am a very small fraction of a mile tall, yeah? So there's lots of different units that we could use to measure height, super. Same kind of idea for weight. Right now you guys all have a sense of what your weight is measured in what unit? Pounds. Almost all of the rest of the world would measure our weight in what unit? Kilograms, right? The metric system is kilograms. And so we've got all of these unit words here. And if you're not sure which one is which, so for example, I know that time and hours are somehow related to each other. If you throw a random number in front of each of those words, the one that makes sense is the unit word. So if I just pick a random number, somebody shout one out. 6 time or 6 hours. Which one makes sense? 6 hours, which means that hours, where is it? Hours is the unit word, and the other guy is therefore the quantity. You can measure time in the unit of hours, okay? All right, so we talk all about this unit and quantity stuff because we're about to introduce a variable here. I need to figure out how many people in this group will make it so that the total cost for each of us is $2,500. So we're going to introduce a variable. How about we call it X? Pick any letter you wish. And we're going to do the calculation in just a second, and we're going to mimic exactly what we did with the specific numbers, but we'll do it with this general variable. But before we do, we got to define what X represents. Let X equal. What does X represent in this problem? Jasper. Number of additional persons. Fine. I'll just write number of persons. All right, that's how many people in our group. And I just want to highlight that we have a quantity word and we have a unit word. Which one of those is the unit word, which is the guy that makes sense when it has a number in front of it? 6 number or 6 persons? Which one makes sense? 6 persons. That makes this our unit word. What's the quantity word? Is number. Number is kind of this catch-all quantity word, but you'll note that it is up there in our list of some quantity words. And we're going to write down an equation in a second, but oftentimes people write equations with x's in them without defining their variable. And if you do that, you're going to lose points on any test or quiz that I give you. And there are 2 reasons that I'm going to take points off if you don't define your variable. And I'll be clear in the problem. Be sure to define your variable. Some of you will ignore those directions, but they will be there. So there's 2 reasons. that I'm going to take points off if you don't define your variable. Number one, the thing that you use to represent, the thing that x represents in your equation might be different from the thing that x represents in somebody else's equation, right? Or somebody could use a completely different letter representing the same thing or a different thing. And your job as mathematicians is to communicate effectively with the reader, that's me, and if you don't tell me what your x is and it just comes out of a hat and it's only in your head but not on the paper, there's really no way for me to know what you are thinking and to grade the accuracy of your equation. The more important reason that I'm going to take points off is that oftentimes people try to jump directly to the equation, to translate all the words into some equation, but if you don't have a clear sense of what your variable represents, like let x equal the number of persons, you really have very little hope of writing an equation, of translating. If it is murky in your mind what x represents, translating to an equation becomes a near impossible feat. The good news for you is that in just about every word problem, it will be really clear what your variable should represent as long as you know where to look. It's in the actual question. There's only one question mark in this problem. It's right here. And in that question, I'm telling you what I want you to find, and that's going to be what x represents. How large a group? This is x. We translated it to number of people, but x is how large a group we're going to have, right? And if you just go to the question, you will find exactly what you should define your variable to be. It's an important step, but it's a really easy step as long as you know where to go. Okay, so let's mimic our calculation from up above. Go here. The first thing we did was 10 times $1.75. Then it became 50 times $1.75. What is it now? X times $1.75. Yeah. It's the number of people times $1.75, that discount per person. I'll write that as 1.75x. So that's like the 8750, that's the discount. In the first row, it was, what was it here? 2752 minus the discount of 1750. In the next row, it was 2752 minus the 8750. What should it be here? That's it. You see, it's the same exact pattern. 2752 minus whatever the discount is. It's really easy with numbers. It is a leap in difficulty to do it with this abstract concept of x, but if you understand the pattern, if you establish a pattern with the numbers, oftentimes makes it much easier. Okay, so that right there is our cost per person, 2752 minus 1.75x. Okay, so I think we're ready now to get the equation. The ultimate goal of this was to get the cost down to $2,500 per person. But that last purple thing I wrote is the cost per person. So what's our equation? There you go. It's the only place the 2,500 comes in, just at the very end. You make it so that the cost is 2,500. Okay, so you guys with your neighbors are going to solve that equation in just a moment, but before we do, let me pause and I'll say the last thing I'm going to say today. Really, really important technique, the technique for the day. I know that word problems are quite problematic. They're difficult for a lot of people. Many of us have this like mental wall that we've put up that just says, I can't do word problems. And that is not the case. This is a way to get your foot in the door with a word problem. You're seeing something, if you can go directly to that equation or that expression with the x in it, fantastic. Lucky you. But for the rest of us, just plug a number in. And oftentimes plugging a single number in, just make something up, will give you all of the insight that you need in order to get to this abstract thing with x in it, all right? Okay, so your job, solve this equation with your neighbors. The answer is on the next page, but don't check until you check with your neighbors, and then go through the activities. I will walk around and help.